Okay, hello everyone, I'm Sagar and this is part 15 from my tutorial, a tutorial for writing a real-time operating system for ARM Cortex-M microcontroller. In previous part, we have installed a cross compiler for our work in Linux operating system. And now, with our compiler that we have installed, I want to write a bare metal program I want to compile and link a bare metal program for ARM microcontroller in Cortex-M microcontroller in Linux operating system. So let's open my digital pen and give you some information. So now we want to compile and link a program, okay, a program, and we need some configuration and some files. Okay, let's open our terminal, and before that let's create a directory, for example mkdir and test. Okay, cd2 test. Now I'm in test directory, and in this directory I want to create a main.c file. Okay, no main.c. Open that, and I want to write a free function and maybe useless function in my file. Okay, void main. It's a free function, okay, and it has no contents. But as you can see, the definition of function is with void. Okay, your return type is void. When you write a main function, okay, a main function for writing a code in, for example, in a Linux target on Windows target compiler. Okay, for example, when you write a main function in your Linux operating system, you need to define your function as an integer return type. Okay, but in bare metal you can have any return type for your function. Okay, and I define my function as a void function. Okay, let's just save that. And now I have a main function. A contentless function, and I want to compile this function with ARM GCC compiler. Okay, with ARM GCC compiler. So what's our compiler? ARM non-EABI and GCC. Okay, here is my compiler, and I want to compile my code with this compiler, but I want to create an object file. So I need -c for creating an object file, and we need some specific options. One of that you need to have when you want to compile with this compiler, you need to specify your processor. Okay, you need to specify your processor. And what's our processor? Our processor is Cortex-M7, because as I said in previous part, I want to test my programs in this course in STM32F4 F746 board. Okay, and the processor of this microcontroller and this board is Cortex-M7. So I need to specify my processor, and with -m CPU option you can specify your processor. And what's my processor? Cortex M7. You can have, for example, Cortex M4, M3, or M0, or M0 Plus, and other processors. Okay, but I have a Cortex M processor. So how can I study about these options? Let's do open GCC documentation. And in GCC documentation, in GCC manual, go to option summary, and search for example, -f -m CPU. Okay, here we have a link, machine dependent options. Okay, machine dependent options. Click on that, and you have some sublinks. For example, all of these links is for a page for some options for GCC. Okay, for example, here ARM options, machine dependence. It's related to one architecture. For example, ARM ARC processor, AMD processor, ARM 64-bit processor, or other processor. For example, Niles processor from Ultra and other architectures. But our processor is based on ARM 32-bit, and search for another time -m CPU. It's option here, M CPU equal name of your processor. But how can I find the list of names? As you can see here, as specified by mtune, you can find list here in mtune. Okay, you have some processor list here. For example, Cortex A15, Cortex A35, for example, Cortex M4, and our processor is Cortex M7. Okay, Cortex M7, and you should add this option to your compiling option, because if you don't add this option, GCC will add a default value for this option. Okay, after that you need another object, mthumb. Okay, what thumb and what is ARM instruction set instruction, or this option? After teaching assembly programming and ARM architecture in future parts, I will teach you what's a thumb in ARM. Okay, but in this time you need to add this option for compiling. After that, you need to give the name of your file, main.c, and output is main.o. Okay, here is minimum options that you need to compile a project, a C file with this compiler. Press enter. Now I have an object file. Assume that don't add, for example, mCPU and mthumb to my project. Let's do this compiling in verbose mode. Okay, in verbose mode. As you can see here, we have some options. Okay, -v verbose mode, -c for creating object file, -o.main.o. But you have this object, mCPU is ARM7 TDMI. Okay, if you don't add your CPU name, compiler will add a default value, and it's a processor for ARM, and its architecture is ARM version 4. Okay, so one of ARM processor. And for example, mfloat, other options that I will teach about them. Okay, so let's another time add. You should add mCPU, Cortex M7, and mthumb. Okay, let's do delete verbose mode option, and with this options and with this command you will have a object file. Okay, here you have an object file. But let's still go to this program. To start a basic project, basic project with minimum options and minimum prerequisites. Okay, you need some files. You need some files, okay, to compile, to create a project, okay. And one of those files known as startup file. Often startup is an assembly file, but you can write this startup in C, okay. But often this startup is an assembly file. And what's a startup file, and how can I find startup or write the startup file? Okay, what's a startup file? Does some initialization. Some initialization. When does this initialization? Before jumping to main. Okay, before jumping to main function. And when your processor and your microcontroller start to processing your files and your output files, your processor will start from your startup file, okay, and does some initialization before jumping to main function. Okay, so often and many of time this file is provided and has been provided by your chip manufacturer, okay, by your chip manufacturer. For example, sorry, assume that you have NXP, Texas Instrument, or ST Microelectronic, or Cypress microcontroller. Okay, you should go to your chip manufacturer website and ask for this file or download this file from your chip manufacturer website. So let's do find a startup file for microcontroller STM32. You can search for STM32 cube. Okay, here is some library and some file that is provided and has been provided by ST Microelectronic. Here in this link, open ST Microelectronic website and scroll down here. So what's the family of my board microcontroller? STM32 F7. Okay, here click on F7 and you can click on each of this link, F7. And now in this page you can download your SDK and libraries and your files here, and you can select your version and download that, get software, or for example get from GitHub website. And there is another way to download this package. Okay, download this package if you have STM32 Cube IDE, or for example Cube MX. Okay, but I have Cube IDE. Open your IDE from Microelectronic, and after opening the software, let's do first open software. Okay, it takes some time because my laptop is not so powerful. Okay, here click on help here in your menu. Okay, click on help and click on manage embedded software package. Okay, here manage embedded software packages. Okay, in this dialog and in this page you have a list of your the family of microcontrollers from ST Microelectronic, okay? And for example, you can download for STM32F7, and I've downloaded that, okay? For example, you can download for STM-F4 family. Check that and install, okay? In this way, you can download the package, and when you download the package, you will have the package here, okay? You will have the package here in a STM32Cube directory, okay? Open that, open repository, and in this directory, okay? And in this directory is for STM32, open drivers, okay? And you have some function, but if you want to find your startup file, open drivers, go to CMSIS, go to device, okay, go to device, open this subdirectory, and here in source, okay, here in source directory, okay, in templates, you will have 3 subdirectories. One of that is for ARM compiler, one of that is for GCC ARM compiler. We said in previous part that you have 2 compiler in ARM website, one ARM compiler and another GCC ARM compiler. But there is another compiler is IAR or UR compiler, but we need GCC compiler. Open that, and you have some startup file for some microcontroller in F7 family, okay? Here is my microcontroller, F746, okay? It's .s, an assembly file, okay? Copy that and go to your test project and paste it here, okay? Now I have a startup file. So how can I compile this startup file and create an object file? Another time, go to terminal. It's so easy, let's do copy. Like compiling C, it's just like compiling C, but you should give the name of your file, startup.s-o2 startup.o, okay? Create an object file from this assembly file. The options is just like compiling a C file, mcpu, mthumb, and -c for creating an object file. Press enter. Now I have a main.c file, a startup file, assembly file, and an object file from main and start. Okay, 2 object files. I said how you can download a startup file, for example, for STM32. Let's do repeat or works for another microcontroller, for example, for NXP microcontroller. For example, you can have another microcontroller, but let's do test and download this startup file for Cortex-M microcontrollers. So how can I download for example, a NXP microcontroller? Okay, NXP microcontroller. Okay, so in this time, search for MCU expresso.nxp.com. Okay, nxp.com, and press enter. Now you are in this website. MCU expresso NXP. In this website, you can download some file and libraries for NXP microcontrollers. Okay, and here you can find your startup file, and you can download a package that contains startup file. So you should click here, select a development port. After that, you should sign into NXP site. Okay, and after that, you will be direct to MCU Expresso SDK builder. Okay, let's do sign in and open the website. Okay, now I have signed in to my login page in this website, and I can create a package for myself for a specific board or processor. Okay, for example, let's select a board from NXP and IMX microcontroller, powerful microcontroller, for example, IMX 1064. Okay, it's evaluation kit for this microcontroller from NXP. Select your version and click on Build MCU Espresso SDK package. Okay, it will create a package for it, and here you should add your host OS. Here, for example, Linux, and your toolchain, and I want a bare metal package. Okay, for bare metal programming. And here you can add some middleware to your project, but I don't need them. Okay, and here you can download SDK. Here you can download SDK. Click download SDK and agree that to download. Okay, you can click download SDK archive. Okay, click that and download this file. Okay, and I downloaded this file before, and I have this package in my download directory. Okay, here in my download directory I have a package for SDK for evaluation kit. Okay, here you can open that, and in this zip file, in this extracted file, go to here. You should go to device. Okay, go to device, name of your microcontroller, and here in GCC. Okay, in this package you just have for GCC because I select GCC for my toolchain. Okay, open that, and here you have assembly file, but in this time the extension of assembly file is in uppercase S. Okay, you can write this extension in uppercase or lowercase s. Okay, both is true, and you can use this startup file if you have, for example, NXP microcontroller, and if you have another microcontroller from another chip manufacturer, you can ask for your startup file from your chip manufacturer website. Okay, contact them and ask for this file, or for example search in their website and download a package that contains this startup file. Okay, you need this startup file if you want to write a standard, but after teaching assembly programming and ARM computer architecture in future parts, I will teach you how you can write this startup file. Okay, I will teach you, but in this time it's better to download a ready file. Okay, you can, for example, you can download for all microcontroller from other chip manufacturers. Okay, now I add this startup file to my project and I downloaded that. As you can see, for STM32Cube is with lowercase, but for NXP is with uppercase S, and both is true. You can have an assembly file with uppercase or lowercase s as an extension of your file. But when you add startup file to your project, you need add another function to your file. Okay, you need add another function to your project. Why? Because before going to main function, if you where is test, open your startup file, search for system handler, systemInit. Okay, systemInit. Before jumping to main function here, your code will jump to another function. Here is a assembly instruction for jumping to a function. Okay, so when you want to use this startup file, you need to add this systemInit function. You need a systemInit function, a function with this name, systemInit, to your function. We need to add this function, and you can see systemInit in other startup files. For example, for NXP, let's do device GCC startup file. You have systemInit here, okay, before jumping to main. So when you add this startup file to your project, you need to add another file, another function to your project. I can write this function in a specific file, and I can add it to my main. Let's add it to main.c. No, main.c. Open that and add another function. The return value is not important. The name of your function is systemInit, okay, with capital S and capital I. Okay, this function doesn't have any argument, and first let's do write a contentless function, okay, but in future part, in next part, I will add this function to my project that does some things, okay, but here I don't want to do a real and very real project. I just want to say you how you can compile and link a project, okay. But many of time this systemInit function do some work for your microcontrollers. For example, initial your internal crystal and initial some power up for your microcontroller and these things, okay. But in this time you need to add this function to your project for linking your project, okay. Let's save that, and another time recompile my main.c. okay, here I have two object file, main.o and startup.o, and in this time I need to link these two object files and create an executable file, okay, create an executable file. But let's open that. To start a basic project, you need some files. One of that is a startup, and for linking we need another file. And what's that file? It's known as linker script, and you should give this file download and find this file or write this file by yourself. But in this part I download this file and add it to your linker, okay, and give it to your linker to link your object files, okay. But for ARM compiler, not GCC compiler. In GCC compiler it's known as linker script, but in ARM compiler is known as scatter file. You may have heard this name, okay, but for GCC is known as linker script, and the extension of this file for GCC is .ld, okay, is a .ld file. The extension of file is ld. So what's a linker script file? What's the linker script file? Is for memory layout, okay, it's for memory layout. So what's memory layout? Let's define what's memory layout. This file give some informations about your internal and external memory of your chip. For example, for what's the internal memory in my chip? For example, I have flash, I have SRAM, or I can add SDRAM to my board. Okay, and these types of memory. Give this information. What's information? The start of, for example, your flash memory and the length of your flash memory, okay? Or start of your SDRAM or SRAM and length of your this memory to create your executable file, okay? So you need to give this file to your linker to know about internal and external memory of your chip, okay? And give some information about code sections. What's code sections? After teaching assembly programming, you will find what sections, okay? Now here you need to add in this file, give some information about your memories and your sections to linker, okay? But like a startup file, this file often is provided and has been provided by your chip manufacturer or your board manufacturer, okay? And how can I find this file? For example, for STM32 microcontroller, another time go to STM32Cube repository, this directory, and in this time go to your projects, okay? And go to your specific board here. It's my development board. And go to, for example, go to example, here example. And go to one of these directories. It's not important which directory, for example, ADC. And go to these subdirectories. SW4ST, STM32. In this directory, you will have a .ld file. Okay, .ld file. And you can use this LD file for all of microcontroller F746. Okay, copy that, go to home, go to this and paste it here. Okay, let's open that. I will teach you about the structure and syntax of this file. Okay, after in next parts, in future parts. Okay, in future parts I will give you some info. I will teach you how you can write your linker script, but in this time you can find it in your STM32Cube package, or for example for NXP you can find it here, NXP microcontroller, for example, another time in device directory and another time in GCC. You have more than one LD file, because for example when you add a STRAM to your board you need to create another memory layout for your linker, okay? But for basic chip or your basic chips without any external memory, you can use this file, okay? Like from ST, it has some information about your memory, okay? And you should give this to linker. And I wanna link my project with this file. But before that, let's go to home, go test. And now it's better to create a make file to make my compiling and linking process easier. Okay, that's a nano make file. Okay, nano make file, and write a make file for my project. Okay, here is two rules for creating main.o and startup.o with command and its options, their options. Okay, but let's do create a default goal for link my project. The name of, for example, my output is output. And what's the extension of file for my microcontroller executable file? Is .elf. Okay, what's elf file? It's a standard for creating object file and executable file. Okay, it's a standard for object file and executable file. Okay, and how can I find what's the structure of elf file? I will teach you. Okay, don't worry, I will teach you. But make sure in this part, you add .elf as your object file, as your executable file, output file. Okay, and let's create a objects variable for my object, and let's define objects. What's my objects? Main.o, and sorry, this file. Okay, it's my objects, and you should clear your output.elf. So what's the command of creating elf file? Okay, like before, you can use ARM EABI and another time GCC. GCC is a compiler, but in a better definition is a driver compiler. It's not just a compiler for creating object file. Okay, it's a driver program, driver application. What's a driver in compiling? With a driver compiler, you can compile your project, assemble your project, and link your project and other things. Okay, you can do all of things with this application. And for example, you don't need to use LD just for linking, because this stage is linking. You can use GCC, okay, because GCC is a driver. But what's the options? Like before, you should give your CPU name to linker. Okay, what's the CPU name? Cortex M7. Okay, because your output is a ELF file and your input is object file, GCC will give these options to your linker. Okay, another time thumb. Okay, and you need to give your linker a script file to linker this file. Okay, let's copy the name of this file, and you should give it to your linking stage with dash and uppercase T, capital T, and name of your linker script. In this way, you can give your linker script to link stage. Okay, after, you need to add some libraries to your linking process, and it's necessary. What's those libraries? One of that is libc-lc, means libc.a, and -l no sys, and the name of this library is libnoSys.a, and we write it with -lc. Okay, but I can give the name of this library in another way, that it's more common. It's more common to give in this way. Instead, write the name of every library. What's the option? You can give a spec file. Okay, you can give it specs file, this option, to your link stage. And what's the file? What's the name of file? nosys.specs. Okay, you can give this option to your linking stage instead of give -lc and -l no sys. and this way is more common. Okay, this way is more common. And where is this file and what's this option? Let's go to home directory of your compiler, open this directory, ARM non-EABI, go to lib, and your file is here. Okay, what's the structure and syntax of this file? You can study about the structure of this file in your GCC documentation, but it's not necessary to know this structure because this file is defined and is predefined in your compiler. Okay, and you don't need to define a new file for your compiling stage. Okay, many of time we use this file, none of that specs, but for minimum option and minimum requirement, you can add nosys. Okay, and it will add -lc and -l nosys to your object stage. Okay, and it's more common to give this option instead of -lc and -nosys. Okay, and after that, name of your object file and name of your output file. Okay, main.o, another time startup object here, copy that and paste it here, and -o, name of your output file, output.elf. Okay, here is all options, all file and all command to create an executable file, ELF file, from my input files. Okay, let's just save that and see it in GUI. Make file. In this way is minimum requirements for creating an executable file. You can write your minimum requirements and your basic project in other ways, but if you want to observe standards of GPU manufacturers and ARM company, it's better to write your minimum and basic project in this way. Okay, you need a main function, you need a systemInit function, you need a startup file, and you need a linker script, and you need two libraries that you can give to your link stage in this way, -lc and -l nosys. Okay, and let's compile my project with my make file. Make clean. I have my startup file, my main file, and my linker script. Let's make my project. Now let's compile my main.c, let's compile my startup assembly file and create object file, and the last command is create an ELF file. Okay, without any error. Okay, without any error. And now I have a contentless functions, for example main.c and systemHandler.c. In the next part, I will give you some information about CMCs and a standard from ARM company, and I will write a real project for my board. Okay, to turn on an LED on my board. Okay, so now you know how you can create a basic project. In the next part, we will turn on an LED. Okay, so basic project with ARM GCC compiler in Linux operating system. Thank you very much for watching this part, and see you soon in the next part.